if we're going to figure out which gas effuses at a rate of 1.5 times that of chlorine gas, we have to refer back to our equation for effusion rate or diffusion rate. So if we have gas 1 and we're comparing it to gas 2, that rate, so the rate of 1 to 2, like the comparison, is equal to the MR of 2 over the MR of 1. MR stands for the molecular mass. So let's do this. So our rate is 1.5, and our molar mass of number 2, which we would say, we'll call this chlorine, and this our unknown. So for chlorine, we have 70.9 grams per mole. And then for gas number 1, which we do not know, I'll just say X. So you just solve for X. So you square both sides, and you get 1.5, and then squared is equal to 70.9 over X. So then you can say X is equal to 70.9 over 1.5 squared. And this gives you 31.5 grams per mole. So that's the molar mass of X as a gas. Now if we were to look at some gases that could have similar molar masses, we can say, well, nitrogen gas has a molar mass of 28 grams per mole, but that's not close enough. We can say fluorine gas, that has a molar mass of 38. Still not close enough. Well, we can say bromine gas. No. Bromine gas is too big. What about oxygen gas? We said oxygen gas. Well, that's a molar mass of 32. That seems kind of close enough. Well, helium gas is about. It's a neon. It's a noble gas, so it's not a diatomic. This will just have be a molar mass 2. Clearly not it. So we might say oxygen is it. Well, we have two significant figures here, so we can actually round this if we wanted to 32. And that is pretty close to oxygen. So we can say oxygen diffuses or effuses 1.5 times the rate of chlorine gas.